What's good, Achana? I made like a write-up for this question. This is the one that we struggled with yesterday, but I figured like we talked about how you like to do things in processes, so I figured like a YouTube video just demonstrating how it solves problem would be a little easier. So we got kind of caught up. This is pretty easy. We got kind of caught up with all the separation of variables stuff, but this is kind of different. Just so to reiterate, the goal is we were given this differential equation, dy over dx is equal to 3x plus 2y plus 1. And they said basically, oh, so the solution is this, but y is equal to mx plus b plus e to the power of rx. By the way, Joey, can you get these letters? Okay, cool. My sister's recording it. Anyway, so the goal is to find what m is, what b is, what r is. And they said use the differential equation to do that. So it's really just a question of substitution. What we're gonna do is we're gonna do two substitutions. The first one is we're going to plug in our y into this new equation. So instead of 2y, that's gonna become 2 times mx plus b plus e to the rx, right? That's the first thing we're gonna do. The second thing we're gonna do, and this is where we tripped up, this dy over dx is the same thing as if you differentiated that. So like, if you just differentiated this y, rx, right? If I differentiated that, well, this mx is just gonna become m, right? This b is going to be nothing, and then this e to the rx is going to power rule. This r is going to come down, so r e to the rx. That's where the m plus r e to the rx comes from. So basically what this is saying is this is our new dy over dx is m plus r e to the rx, right? We're here. Okay, so now if I put everything together, if I want to say dy over dx is equal to this, I'm going to plug in, so I have m plus r e rx instead of dy over dx is equal to 3x plus 2 times this whole thing. So I'm actually going to go ahead and distribute. I'm going to say, okay, well, we have 2mx, 2 times b is 2b, 2 times e to the rx is 2e_rx. Like this. And then we have the plus 1 at the end from the original equation. How long is the time, Joey?
3 minutes.
Okay, cool. Alright, so now, let's expand everything. Let's get rid of the parentheses. Rx is equal to 3x plus 2mx plus 2b plus 2e_rx plus 1. So now that grouping stuff that we got to, this is how this works. I know that this side has got to be the same as this side, correct? I also know that this side is a constant term, the m, and it's got an e to the rx term, right? This e to the rx term is going to be replicated by this somehow, because you can't make an e to the rx where there isn't one. And this m term, well, it's a constant, so I'm going to be looking at this and this. Do you notice that there's no x term? That means that there's a 0x on top of this, and that's what this is going to be. So 3x plus 2mx, well, that's just 3 plus 2m, all times x. We know that there is no x in the left side of the equation, so this has to equal 0. Which means m is equal to -3 over 2, right? Well, the other thing we know is 2b plus 1, our constants, on the right side equal the only constant on the left side. So 2b plus 1 is equal to m. We know m is -3/2, so I'm just going to replace that. Sorry for the smudges. So 2b is equal to -3/2 minus 1 is -5/2. b is equal to -5/4. So that's that one, that's this one. And finally, r, well, on the left side you have r to the power of r times e to the power of rx. On the right side you have 2 times e to the power of rx. The reason this r doesn't matter is because it's attached to the variable, but this 2 and this r mean that this r is just equal to 2. So just to recap, you get the first derivative equation, you get the solution equation, you get rid of anything that looks like dy over dx or y. You plug everything in, that substitutes for that. So like you take this equation, you plug it into this, you differentiate this equation, you plug it into this, and then you just work your way down. Set the two things equal, and then see which matches.